All right, mathematicians, we'll look at section 7.4 about our special parallelograms, the rectangles, rhombuses, and squares. All right, in this lesson, we're basically going to look at the properties of special parallelograms. So we want to answer the essential question, what are the properties of rectangles, rhombuses, and squares? All right, so our core concept is about these three special parallelograms. So just pause the video and fill in your notes with the definitions and pictures. Alright, so we have three corollaries that we'll be using in this section. A corollary, just a reminder, is a statement that is true without proving it to be true. So we have the rhombus corollary. It's a quadrilateral is a rhombus if and only if it has four congruent sides. Then we have our rectangle corollary. Quadrilateral is a rectangle if and only if it has four right angles. And a square corollary is a quadrilateral is a square if and only if it is a rhombus and a rectangle. Alright, for sure if a quadrilateral is a square, then it is a rhombus and a rectangle. So what this means is that if it's a square, this implies that it has all the properties of a rectangle and rhombus. So that means all four sides are congruent, all four angles are right, perpendicular diagonals are also congruent, and the diagonals bisect the opposite angles. So let's take a look at an example ABCD. We know that the property of squares is that it has all four right angles because it has the same properties as a rectangle. And we also know that the diagonals bisect opposite angles. So if I know that any of the angles are right, in other words 90 degrees, and diagonals bisect, then that makes each angle at the right angle congruent. So let's set up our equation. If measure of angle DAC is 9x, find x. So our equation is 9x equals 45. Then we solve for x by dividing 9 on both sides, and we get a result of x equaling 5. Sorry about that. The screen said y equals 5, so I just fixed it to say x equals 5. Next, let's look at our rhombus theorems. A rhombus has all the properties of parallelogram plus a few more. So if a quadrilateral is a rhombus, then it has four congruent sides. So go ahead and mark up your picture with four congruent marks on each side, one mark on each side. And our implied is that a rhombus implies equilateral parallelogram. Next, we have diagonals are perpendicular. And if diagonals are perpendicular, that means it forms a right angle right there in the middle. So we can say a rhombus implies with perpendicular diagonals. And then the third feature or property we have is diagonals bisect opposite angles. So this diagonal will cut this angle into two equal angles, and this diagonal does the same thing with its intercepting angles. So a rhombus implies with diagonals bisecting the interior angles. So our rhombus diagonals theorem states that a parallelogram is a rhombus if and only if its diagonals are perpendicular. And we can see that here. We have to see our arrows indicating parallelogram. Now we have a rhombus opposite angles theorem. Parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. All right, let's look at this example. For any rhombus QRST, decide whether the statement is always or sometimes true. Draw a diagram and explain your reasoning. Alright, so once you kind of have your diagram in place for a rhombus, take a look at everything that's going on in the picture. You have opposite angles congruent, you have all four sides congruent. So I'm being asked whether angle Q congruent to angle S is always or sometimes true. Well, by definition, a rhombus is a parallelogram with four congruent sides. So by the parallelogram opposite angles theorem, in other words, if a parallelogram implies opposite angles congruent, then our opposite angles are congruent, so angle Q is congruent to angle S, and this statement is always true. And for part B, I drew a separate diagram. If rhombus QRST is a square, then all four angles are congruent, right angles, so angle Q congruent to angle R when QRST is a square. Because not all rhombuses are squares, the statement is sometimes true. All right, take a look at this diagram, classify the special quadrilateral, and then explain your reasoning. So we see that all four sides are marked congruent. So by the rhombus corollary, the quadrilateral is a rhombus. And because one of the angles is not a right angle, the rhombus cannot be a square. All right, so reflect on all the properties of a rhombus and try to fill in all the measurements of angles 1 through 6 with this given picture. So pause the video and try these on your own. Okay, we can first identify that angle 2 is 35 degrees because we know that diagonals bisect the angles. So if the diagonals bisect the angle and I'm given 35 degrees for one part of the angle, then that means the other angle is also 35 degrees. Next, I could look at the property that diagonals are perpendicular. So that means angles 3 and 4 there in the middle are going to each be 90 degrees. Next, I can look at the property of consecutive angles being supplementary. So if I know that angle 2 and the 35, they're both 35, so that becomes 70 degrees. So measure of angle 5, which is opposite, would be 70 degrees. And then I can subtract 70 from 180 to get the supplement, which would be 110. So measure of angle 1 would be half of that, 55 degrees. And then angle 6 would be 110 degrees. All right, so now that we've done an example kind of together, maybe try this one on your own. So pause the video and see if you can figure out all the missing angle measurements here for 1, 2, 3, and 4. All right, so just using your rhombus diagonals theorem and the rhombus opposite angles theorem, we can conclude that measure of angle 1 is 90 degrees because diagonals of a rhombus are perpendicular. Measure of angle 2 is 61 degrees because of alternate interior angles. Our alternate interior angles are a result of AB, side AB, and side DC being parallel. So you have angle 2 and the 61 degrees, both alternating. And then measure of angle 3 is going to be 61 because diagonals bisect angles. And then if you can add all those angles, 1, 3, and 4, to total 180 degrees because it's a triangle. And we know the 90 and the 61 because angle 1 was 90 degrees and angle 3 was 60 degrees. So we'd add those up, subtract from 180, so measure of angle 4 must be 29 degrees. So measure of angle 1 is 90 degrees, measure of angle 2 is 61, measure of angle 3 is 61, and measure of angle 4 29. All right, next we have our theorems for a rectangle. So a rectangle has all the properties of parallelogram plus a few more. So if a quadrilateral is a rectangle, then it is equal angular. So mark up your picture with all equal all equal angles. It is also diagonals are congruent. So mark that your diagonals are going to be equal in length. And then the 4 right angles. All right, so that gets us our rectangle diagonals theorem, which states that a parallelogram is a rectangle if and only if its diagonals are congruent. So that would be enough to conclude that it's a rectangle when the diagonals are congruent. And then you have all the other properties as well that you can use. So let's take a look at this example and see if we can figure this one out. So we know that QRST is a rectangle. We're given that information. So if QS equals x plus 16, RT equals 3x minus 4, and the measure of angle R equals 2y plus 34, we want to find x and y. So we can say that opposite sides are congruent. So QS is equal to RT. Therefore, we substitute the x plus 16 equals 3x minus 4, and then from here, use your math algebra skills to solve for x. All right, so we do all our math steps, our algebra steps, solving, combining like terms, and we get a result of x equaling 10. Next, we know that angle R is a right angle, so we can set up an equation of 2y plus 34 equals 90 degrees since our right angle is 90 degrees. And then just use your math algebra skills to solve for y. All right, so we should have y equals 28. All right, let's take a minute to look at this real-world application where we can look at a window frame and see if it is indeed a rectangle. Can we assume that this is a rectangle? And then measuring the diagonals of the opening, the diagonals are 54.8 inches and 55.3 inches. So what can we conclude about the shape of the opening? So two different parts that we're looking at. So the answer to the first part A, no, we cannot assume that this is a rectangle. Although the opposite sides are the same length, we do not know whether we have right angles or not. And we must know that if there are right angles, then we can say that it is a rectangle. And then the second part, part B, by the rectangle diagonals theorem, that states that diagonals are congruent, we can conclude that the diagonals of the quadrilateral formed by the boards are not congruent. So the boards do not form a rectangle. All right, so I want you to try example number 5, knowing that the property for rectangles, one of the properties is that diagonals are congruent. So set up an equation and solve for x. Find the lengths of the diagonals of QRST, parallelogram QRST. Okay, let's check your answers. Did you get that x equals 14? And then once you substitute 14 back into your two different expressions, you get a length of QS and the length of RT, since they're congruent, at 39 units. All right, now let's look at parallelograms in the coordinate plane. Once again, we want to decide whether parallelogram ABCD with the following vertices is a rectangle, a rhombus, or a square. And we want to give all the names that apply. So this requires us to look at the slopes for the parallel, opposite sides parallel. We can look at lengths of sides to compare all the sides. That's the distance formula. Okay, so we know we can look at the lengths of AC and BD, the diagonals, and that's using the distance formula. So plugging in the x and y values for the vertices, we have from A to C is a distance of square root of 72, which simplifies to 6 square root of 2. And then the length or distance from B to D, when you use the distance formula, comes out to be square root of 200, and that simplifies to 10 square root of 2. So if we compare, they are not congruent. So this helps us conclude that it is neither a rectangle nor a square. Next, we can look at the slopes of the diagonals. So the slope of diagonal AC comes out to be -1. The slope of diagonal BD comes out to be +1. When we multiply those slopes, it comes out to be -1, which means the diagonals are perpendicular. So we can conclude that parallelogram ABCD is a rhombus, since the diagonals are perpendicular. All right, this is a great diagram to help us understand all the properties of our quadrilaterals, so we'll kind of refer to this chart throughout the next couple of videos. But for now, at the end of this video, we want to look at, from quadrilaterals, we've got our parallelogram, and then from the parallelogram, have the properties of a rectangle and a rhombus, but they're different, so that's why they have a split there. And then you know that the square has all the same properties as a rectangle and a rhombus. So as we're using this chart, we want to be able to answer true-false questions using a method that helps us answer true-false questions easily. So if you draw an arrow on the right side of your chart, as seen here, going up, so have your arrow going up along the chart and write the word true, and then next to that have an arrow going down and write the word false. So let's look at a couple of examples that allow us to use this method to help us answer true-false questions. All right, the way the chart works is we start with the statement we're given and what shape is mentioned in the statement. So for number 1, we're looking at a rhombus. Then we look at the property, and it's mentioning diagonals bisect. Diagonals bisecting each other is a parallelogram. So we circle the rhombus and we point an arrow towards the parallelogram. That means if the arrow is going up, then that means true. All right, for number 2, we're also looking at a rhombus, and then we're looking at the properties of consecutive angles congruent. And that requires our arrow to go up towards the parallelogram and then back down towards the rectangle. So if any part of your arrow is going down, then it is false. All right, now we're looking at our last statement that also has to do with the rhombus and the properties consecutive sides congruent. Well, that's referring to a rhombus, so we're not drawing any arrows, so a rhombus property has rhombus properties, so of course that's going to be true. All right, so this concludes our lesson for today, so bring your notes and all your properties tomorrow and we'll practice in class.